Hello friends, welcome to my YouTube channel Basic Electrical. Today we have discussed about the problems related to the symmetrical components. So the question is that one conductor of a three-phase line is open and the current flowing through the delta connected load, okay, through the line A is 10 ampere with the current of the line A as the reference and assuming the line C is open. Okay, so find the symmetrical component of the currents. So first of all we have to draw the delta connection. Okay, so that is the question mentioned that there is a delta connection. Okay, first of all I have draw the delta connection. Okay, so there is the three line, that is A, B and the C. So the line C in the question is mentioned that it is open. So here I have mentioned that is line C is open. Okay, line C is open. So here that is the current is flowing IB, here current is flowing IC and here current is flowing IA. So in the question mention that is current IA is 10 ampere. Okay, so current IA is 10 ampere in the question mentioned that. Also mentioned that the line A is the reference. Okay, so we have taken that IA is equal to 10 angle 0 degree, that is the reference. Okay, so IB is, what is the value of IB? Okay, so IB is basically that is the current in the line B. Okay, so here in the question mentioned the three phase line and the current of the load A is 10 ampere with the current in the line as the A is the reference. So here the C is open is that, so IC here is open, that is 0 and the IB is also 10 with the shifting of 180 degree. Okay, now we have to calculate the symmetrical components. Okay, so what is the symmetrical components? That is IA0, IA1 and also we have to calculate IA2, similar IB0, IB1 and IB2, similar we have to calculate IC1, IC2 and IC0. So these are the parameters we have to calculate. So how to calculate the value of IA0, IA1, IA2? Okay, so first of all we have calculate these values. Okay, so first of all here that is IA0 is equal to 1 upon 3, that is of IA plus IB plus IC. So here that is 1 upon 3, IA value is given 10 angle 0 plus IB value is given 10 angle 180 degree because shifting is that is the reference, base reference is 10 ampere, so 10 and the shifting is 180 degree angle plus IC0. So here we have to calculate it 1 upon 3 and 10 is, that is 10 cos 0 plus j 10 j10 sin 0 plus 10 cos 180 plus j10 sin 180 degree. Okay, so that is the value I have calculated, that is 1 plus all the parameters are 0. So all the parameters are 0, so that is the value is what is the value here? Sorry, this value is cos 0 is 1. Okay, and this value sin 0 is 0 and this value is here 1 minus 1. Okay, and then 0. So this one and this one is cancelled out, so the value is IA0 is 0. Similar way we have to calculate the value is IA1 and IA2. So first of all that is IA1, what is 1 upon 3 IA plus alpha IB plus alpha square IC. Okay, so you have to substitute all these values. I have discussed already about that. What is the alpha is basically 1 angle 120 degree and IB value is given 10 angle, sorry, okay, 1 angle 120 into IB value is 10 angle 180 plus alpha square 1 minus 120 into IC value is 0. Okay, so we have calculated the value of IA1. Okay, so that is IA1 value is we have calculated 5.78 and angle minus 30 degree. Okay, now we have to come to the parameter of IA2, that is 1 upon 3, and value is IA plus alpha square IB plus alpha IC. Okay, so here in this case IA2 is equal to 1 upon 3. Now value is given, IA is 10 angle 0 plus alpha square, that is 1 minus 120 into IB is 10 angle 180 plus alpha into IC. So IC value is 0 and alpha value is 1 angle 120 into, that is value is IC is 0. So now we have to come, that is IA2 is, what is the value of IA2 is 5.78 and angle is plus 30 degree. Okay, so these are these things. Now we have to come, since that IB 0 and IA 0 is equal to 0. Okay, because there is the no zero sequence in the IA 0 and IB 0. So now what is IB 1 is equal to alpha square IA 1, and here IB 1 is equal to alpha is value is, what is the value of alpha square, that is 240 degree. Okay, and the I1 I have already calculated 5.78 minus 30 degree. So IB1 is equal to 5.78 and angle is 210. Okay, 240 minus 30 degree, so here 210 is there. Now similar way IB2 is equal to alpha square IA2, sorry, IB2 is basically is alpha into IA2. So IB2 is equal to alpha is 1 angle 120 degree into IA2 is 5.78 and angle plus 30 degree. So IB2 is equal to 5.78 and angle is 150 degree. Okay, similar way IC0 is equal to IA 0 is equal to 0. Okay, so here the value of IC1 is equal to what is the value of IC1? So IC1 is equal to alpha IA1. Here you have to don't confused about that, how to calculate this one and this one. You can easily calculate with the, I have already told about the how to calculate of IA0. Similar way you have to calculate the IB0 and IC0. The value is same thing. Okay, so that's why I have already done that. So I have written directly here, that is 0. So next is that IC1 is equal to, what is that, IC1 is equal to alpha into IA1, and the alpha value is given, that is 120. Okay, angle 120, 1 angle 120 into IA1 is 5.78 and angle minus 30 degree. So IC1 basically 5.78 and angle 90 degree. Okay, similar way IC2 is equal to alpha square IC2. Okay, so the value of what is the value of that thing, we have to put here the value of this. So here IC2 is equal to, what is the value of IC, sorry, what is the value of IC2? Here we have to, that is alpha square is 240 degree and that is 5.78 and angle 30 degree. Okay, so this is not IC2, actually this is IA2. Okay, so that is IC2 is equal to alpha square into IA2. So IA2 value is 5.78 into plus 30 degree. So this value is IC2 is equal to 5.78 and angle 270 degree. So this is the positive, negative and zero sequence of the symmetrical component. Okay, so now we have to move to the next question. So in this question basically you have to see that here it is mentioned that in the question what is that, if three phase 4-wire system is given and the currents in the line A, B, C and abnormal condition of the loading were considered. Okay, so IA, IB and IC is given. So we have to calculate the zero, positive, negative phase sequence currents in line A and the return current in the neutral conductor. Okay, so first of all I have draw that is the system. In the question mentioned that what is 3-phase 4-wire system. Okay, so here you can see that there is the 3-phase 4-wire system, that is 3-phase load and the 3-phase IA, IC and this is IB. So this is 3-phase 4-wire system. Okay, so the zero sequence component of current in line A is given as the zero sequence components of current in line A is given by what is that, IA0 is equal to 1 upon 3, that is IA plus IB plus IC. Okay, so here that is IA0 is equal to 1 upon 3, that is what is the value of IA in the question mentioned that IA is 100 angle 30 degree plus IB is 50 angle 300 degree plus IC is 30 angle 180. So here we have calculated the value of this thing, that is 1 upon 3 and we can write like that in the polar to rectangular coordinate systems. So that is 86.60 plus J50 plus 25 minus J43.30 plus minus 30 plus J0. So that is value is 1 upon 3 and that is 81.6 plus J 6.7. Okay, so IA0 is equal to 27.29 and angle 4.69 degree ampere. Okay, so that is IA0. Now we have to calculate for the line A, that is IA1. So IA1 is equal to 1 upon 3, that is IA plus alpha IB plus alpha square IC. Okay, so that is 1 upon 3 IA, you know that 100 angle 30 plus alpha 1 angle 120 and IB is 50 and angle 300 degree. Okay, plus alpha square 1 angle 240 degree and IC is 30 angle 180 degree. Okay, so you have to calculate the value is what is the value, that is 57.98 and 43.29 degree ampere. Okay, similar way you have to calculate that the IA2, what is the value of IA2. So I have written that is IA2 is equal to 1 upon 3 IA plus alpha square IB plus alpha IC. Okay, so now we have to feed all these values. What is that? So IA2 is equal to 1 upon 3 and that is IA value is 100 angle 30 plus alpha square 1 angle 240 into that is IB value is 50 angle 300 plus alpha is 1 angle 120 into IC is 30 angle 180. Okay, so IA2 is equal to 18.97 and angle is 24.96 degree ampere. Okay, so this is the value of IA1, IA2 and I0. Now we have to calculate the neutral current IN. IN is equal to IA plus IB plus IC, and that is equal to 3 into AI0. So that is 3 into AI0 is 27.29 and angle is 4.69. I have already calculated the value of IA0, so I have substituted that value of IA0 27.29 into 4.69, so that is 81.87 and angle is 4.69 ampere. So I hope that you have to learn how to calculate this IA1, IA2 and IA0 and how to solve this problem. So thank you very much. Please like and subscribe my channel Basic Electrical.